can they get the tools that you use, or are they tools that you've developed? Or, I mean, how does that look? Can they buy them from you, or?
Yep, sure.
So you actually sell the equipment that you use to do these certifications.
Can I just,
Yes.
Mike, before you answer that, can I just say, I want everybody to know that this is not a paid advertisement. I know we don't ever talk.
No, I'm genuinely asking.
Like, honestly, but I'm saying though, like we don't really ever have people on to just talk about kind of their product and service more generality. And I just want people to know that, like, this is honestly, like, we actually like this.
That's true. That's a good point. We should be charging for this. Solid point.
Yeah.
Welcome to the Decode Podcast. We've got Mike Sivigny from CTAC Americas. Mike is a mechanical engineer by education. His career path took him through SMT process engineering, selling screen printers, and now he's the owner and general manager of CTAC Americas and a friend of ours. Welcome, Mike. How are you?
Thank you, guys. Pleasure to be here. Look forward to our chat.
It's going to be fantastic.
Mike, when we were out in California, we did a drive-by, and we noticed that you were on the corner of the street, and I yelled out, Sivigny, and you seen us. What was your thoughts behind that when you first heard it? Because you didn't know we were there, right? And we just rolled our windows down.
I was literally staring at the sky, looking off in the distance, wondering why Daniel wanted to cancel last week's appointment.
And then you hear that on top of it. Wow. Insult to injury. Wow.
Now, Daniel, we know the reason why you canceled, but why did you tell Mike that you canceled? What was your cover story?
I said Sean needed to get his hair done and needed me to cover for him. It's believable, all right? Anyone would believe that.
I don't even know if it's true, and I believe it.
Waiting for two gentlemen for dinner, to head to dinner.
Mike, I did want to lead off on a serious question for you. I know Elias usually does this part, but my question to you is twofold. First, when somebody uses your service, right, how are you analyzing if the machine is good? But then the second part, what do you do after you have your data? And if you could explain kind of the background of what your company actually does, because this is the curious part for me. The rest I don't care about, but I'm curious about this part.
That's like three questions wrapped in one. So what we're doing is measuring, and we have the tools that are able to be set up to measure the machines as they're being used in production, and just as like they're operating in production. So we're doing that to try to really understand with highly accurate glass boards and the tool set that we have to reduce the process variation and really look at the machine capability. And so we set up the test, set up a layout, set up a way to measure the process. And there are ways to measure each and every process in SMT, and all about data collection and objectively collecting that data so that we can analyze it. This is part to your question. And
can you give me like an example though while you're doing it through like the printer setup? Like how would you test the printer?
Yeah, what metrics are you, or what parameters are you able to test? Squeegee pressure, alignment, what all are you testing for?
Yep. So originally 20 something years ago, we designed a wet test to be able to print directly on a glass board and then measure the location of those printed dots on the glass board. And we'd be measuring X, Y, and calculating theta rotation per stroke direction. And most recently, within the last 6 years or so, we developed a tool that allows us to dynamically check the print force and the accuracy during each print stroke. And as a default, we're measuring 4 times during each stroke and monitoring what the force is and then taking that data, those image captures of our tool, which sits in the work nest of the print, and then the camera system of the printer does the manual, or not the manual, but the automatic alignment of visual recognition on our board, and of course up to the stencil. And we've got top light stencil column backlights that are shining down, so that our cameras that are in the work nest tool are looking up. They're looking at contrasted images. And when we see the stencil and see the board in one field of view of our camera, we're snapping a picture, snapping a measurement during that picture, essentially. We're finding the center of the fiducia marks, and we're doing that 4 times during each stroke. Every 1500 milliseconds is the default, but you can set it to whatever you need to in order to collect the data. And you do a series of, basically you're collecting a sample. We collect enough measurements during each stroke. So we'll do, during the first series to collect data on theta, we'll do 10 prints. We'll have 5 in the front stroke, 5 in the rear stroke. Finish, evaluate the data, look at X, Y, and theta, but we're really only concerned about theta because that's what we want to adjust first. Adjusting the theta it basically soft calibrates the X and the Y, because there are components of X and Y in theta, and you need to square up the gantry first so that you're able to maximize the adjustment of X and Y when you get there, which is basically, so we'll take those values and then put them into the global print offset file of the machine, and then run another 10 strokes, 10 prints, collecting the same data. And then we'll analyze it and verify that the adjustments we made for theta are close to 0. And then we'll take the X and Y offsets and adjust those into the machine in each stroke direction. Do the same thing. Verify with another 10 to make sure that what we've collected is close to 0. If we have to fine tune, we'll fine tune. If not, then we run a long series test, 50 cycles. And then we analyze that data and make sure it meets the spec of the machine.
That's so cool.
How often does there deviation after like a year later? Real quick, that's my last question. Like after a year, if you went back and reanalyze that same machine, is there a deviation usually, or?
Absolutely. So we have I think it's 1,200 printers, or 1,800 printers. That's actually closer. Over 1,800 printers, 90% of those printers failed on the initial measurement of the validation for that printer. At the end, 16% were failing that could not be fixed. So there is a very large portion of those machines that drop out of specification after a certain number of months. And I've seen printers that were adjusted by us fall out of spec in 3 months, and others are generally probably in the 6 to 8 month time frame.
Wow. What's the
So
reason?
Do you see I thought that was your last question.
I know. I'm
Sean.
just
What
curious. I'm sorry.
happened?
It's like a detective. I just want to keep knowing more. I'm sorry. Did somebody bump it?
Bump what? Oh, the printer. I mean,
Yeah.
it can be a camera crash. It can be an operator who has a slip up that not paying attention, and something happens, and then they don't tell anybody about it. And then the data collected by the SPI is flagging, something that's going on. And we have some data centric customers that actually informed us of that scenario. And they have a protocol where if their SPI data sees more than 100 micron offset, they stop and they drill into the machine and they figure it out, because the DPMO at the end of the line goes off the rails when there's more than 100 micron offset at print. Quantitatively, that's what they know, and that's what they're using our tool to help figure out and keep their printers optimized.
Wow.
So all this that we're discussing is only applicable to equipment after it's been on the floor for some time. Surely when you buy a new printer, it comes from the factory and it has, certain
It'll always be perfect,
specifications that in terms of accuracy and otherwise. So no need to do that with new equipment.
Exactly.
At what point would you do that then?
with what I know, I would do it at every possible step of the cycle. I mean, the whole cycle, from initial evaluation of a machine that I'm going to consider buying. If I am looking at A versus B, I would do a check there. If I am buying the equipment, I would put a PO contingency in place saying that I want a third-party company to validate the spec of this machine. Then, and I wouldn't pay until that spec was met based on what their brochure says. That's the letter of the law. That's what it says it should do. That's the third-party day that I want to validate it. And then every year thereafter, or whatever frequency makes sense.
So do you see brand new, freshly factory installed and calibrated systems not living up to their advertised specs?
That is probably the lion's share of that 90% of the data that I mentioned.
Yo.
Wow. Wow.
So what?
Are you in like witness protection? I mean, do you have these manufacturers like looking for you, or?
No, but I mean, the big problem is that the calibrations that the OEMs offer do not consider stroke dependent offsets to really fine tune the machine. And that level, you get to this level with the standard calibration from an OEM. When you go to adjusting the offsets with an independent tool, you're able to get the maximum capability adjusted and finely tuned so that and somebody at the show called it super tuning. And I was like, I like that. It's true. I mean, it is what it is. If an OEM doesn't have one of our CM print tools, their systems do not have the capability to be able to adjust and understand what the stroke dependent offsets are, the real performance in the machine. It does. They have a spec and they have a test to test their vision repeatability, but not the full process spec, the full dynamics.
You guys are kind of like taking a car to the mechanic before you make a purchase to make sure you're not getting sold a bill of goods, right? And I imagine some manufacturers, some OEMs might be a little more receptive to that and excited to get their equipment spec'd out and proven, and others maybe trying to hide it from you, right, and keep you from exposing them for their really, really colorful marketing. So
Right.
What's your experience like? And feel free to name names.
Some are very interested, have been for many, many years in developing the tool set to be able to qualify their printers and market them. And there are others that don't want to know, and probably why they haven't. I've engaged with almost all of them, and it's not that I get resistance. It's just that they don't actively want to validate their machine to market it for, what they could get out of it in terms of, selling more machines. I have a CTAC certified decal that we put on the machines when we're doing the test, and I enlarged it and I added, it's now a magnet that we put on the front door of a printer or a placement machine. If an OEM has paid for a validation, you'll start to see more of those on the Apex trade show floor, because it's a
badge of honor.
Kind of. I'm calling it cross marketing because we're offering that service, we're offering that validation, third party independent. So yes, there's a mix of OEMs who are interested and perhaps not interested in testing their equipment.
I just got a good business idea. I'm going to actually make those same magnets and sell them to people for like $50.
Oh, yeah?
Yeah. And then no one will know who's the real one.
So, Mike, you don't just get in there and analyze everything and be like, oh, yeah, it's trash, and then just walk away, right? You're actually taking remediation steps to get things back into square. What does that look like? What are you actually doing mechanically to a screen printer or a pick and place?
To go from 90% failure out of spec to 16% are out of spec.
Mm-hmm. So it is collecting the data, it's analyzing the data, adjusting the offsets into the machine, And if a machine is stable and exhibiting, good stable performance, then we collect all the data, make sure it's finely tuned. We'd run our long test and verify that long test provides good statistical significance to the machine meeting its specification. And then we take that data, the final data, and we write a report. And this goes back to Sean's earlier question: what do we do with the data? That's what we do. We have a reporting format that we use to document the serial number, all the steps that were taken during the test. Everything is documented with tables and graphics and summary, commentary, and it's all written in third person. So it's something that the end user can read and understand what's going on with their equipment. They can use that as, an audit validation tool, especially in the automotive industry. And if there is a problem, we go the extra couple of steps to document where the problem is, why there is variation. I won't say why there's variation, because sometimes we don't know why there's variation, but we can prove that there's variation and that it's not the y-axis, it's the x-axis or whatever it might be. Because when you collect enough sample data, you're able to see how stable that data is just by running the charts and understanding what it is, looking at the numbers and then generating the reports to prove what's going on.
Now, what about like a machine like a selective solder, where it's kind of just some pot moving around? Is there a certification process you go through that, or is it more just printer and surface mount pick and place?
No, we can do. We use an absolute methodology in our software and our vision setup to mount a smart camera in a bracket, and that bracket gets mounted to the nozzle where it's going to move. And we either are looking at the glass from the bottom side, or we're flipping the glass and having it read the fiducials, and then we're looking with the camera at the reference marks in the glass from underneath. And we're recognizing, again, finding the center of the reference mark. We know where that location is based on the fiducial coordinates in the glass. And then we see what actually happens, where it actually makes the measurement.
So like, where does the flux check go? Where does the solder go compared to your target?
So we need to check. We need to know if the repeatability at first, for sure, is the motion, the gantry motion of the table that's going on, down below. We're checking that for repeatability to make sure that it's going to the right location each and every step, and seeing if there's any positive or negative backlash in the system. And that's why we design layouts to try to functionally test the function of the machine and how it's moving in X and Y and, and positive and negative. And when you move, if there's backlash in one direction, you'll see a big offset in one direction. And then if it's going in the opposite direction, you'll see the big offset in the opposite direction. So it's a matter of, in the software, my colleagues in Germany, they have done a really great job at making the statistical analysis very quick. So within minutes of completing a measurement, you can make groups by head, angle, gantry, whatever you want, and understand what those scenarios are. And that's where the big power is in the printing and the placement process, is fine tuning those two process steps. And when you start making the groups and understanding what the associations are, so head 1 at 90, 0, 90, 180, 270, there's an offset for each one of those conditions. Taking those values and putting them back into the machine and then retesting to make sure that our adjustments were correct. So it's literally validating every step that has some type of motion gantry going on to understand where the variation is coming from and trying to suss it out.
If I remember right, you have one of those critical tests that you do on the placement machine would be the Z force, right? And because sometimes people aren't aware that their placement platform might actually be placing too much force on a capacitor and actually been known to crack components, right?
It's very true. I argue the point of that it's more important to measure force than it is accuracy, but both are critical and both should be measured. And so basically what could be causing that crack is the amount of impact energy that's coming through the nozzle as it's depositing the component onto the board. And if it's happening in a very fast way, we get a very steep impact curve, which is the DFDT curve. And when there's that much speed coming down to the board, it creates a lot of impact energy. And that energy is what microfractures the chip body. And that chip body can make it through in-circuit test and make it through final test. And then it will propagate to a full failure in the field once you get to that thermal cycling. And that's the real problem, is that not enough time, not enough effort and energy is spent trying to control that and understand it. And I think that's where a lot of rework comes from, back from the field, when you have those scenarios. And that's a critical failure scenario, especially if it's an ABS module in your braking system and it fails.
Sure.
I mean, it's not good.
Yeah, I can see why you put more emphasis on the placement force, right? Because if your position is off, depending on what the component is, it can be kind of forgiving, right? Reflow can kind of tend to draw things back to where they're supposed to be. But if you've got a crack in the component body, there's no coming back from that.
And even if it doesn't reflow correctly, the defect is obvious in that case. Like if it's skewed off pad, it'll be easily caught by the AOI.
Well, that was the more obvious part of my statement, so I left that for you, teed it up for you.
I feel like I should say the word obvious to join in.
Yeah.
So when you're out in the field and you get called onto an SMT line, 9 times out of 10, who's the worst culprit on the line in terms of which piece of SMT equipment do you see more oftentimes than not being out of whack? It's got to be the placement machines, right?
The statistics say it's the printer, because 60% of the placement machines are failing, with an even smaller number that pass at the end, which is, fail at the end.
And the placement machines don't have stencils that you have to worry about. So that's, makes half the battle easier.
Yes, true. You're fighting an uphill battle, Elias.
The most accurate component within the SMTA process, and it takes the most flack.
So if we want to talk stencil stuff, we talked about this recently, Elias, and even the calibration of stencil lasers need to be checked, because in a wet test, we can run a regression analysis on the squareness of the cutting operation at a laser house where your stencils are being cut. And if there is a calibration issue, it can show up in an image being rotated in the cutting process. And if it's not checked and there's no way to check it before you get it, then the customer gets that rotation and there's no way for the printer to correct for that rotation. It's in there for the life of that stencil, which if you have fine pitch devices out at the corners, it's going to be there to keep those lined up. So you have to think about that also. In terms of you guys, Daniel and Sean, and your operations. I mean, I'm sure that you have Elias stencils and that everything is running great. But
this is where you nod your heads.
keep the check coming, Elias. Yep, right. He's great. No, that's true. I got a question. So you said you take multiple measurements across a squeegee stroke, right? Do you sometimes then see like a big pressure drop once the squeegee reaches the apertures and all the paste is now starting to drop into the apertures? Does it sometimes change pressure at that point, or why is it changing pressure as it moves across?
I've had one scenario, actually a few scenarios, and it depends on what's happening and what the force control mechanism is in the printer, how the head is controlling the force. If it's an encoder motor that's controlling the motor and holding the motor in position once it finds the force, that is like a square wave. It turns on, comes across, turns off. It's nice and square. That tells us that the stroke is repeatable. It tells us how accurate the force level is based on the set point in the machine. And if it's not, then maybe there's a calibration of the squeegee force that needs to be run to recalibrate that offset. And some of the OEMs have dynamic force offsets in their software to compensate for that stuff. The other issue sometimes is pneumatically controlled print force scenarios, or mechanics in their heads. You don't get square wave style force turning on and off like you would expect. There's a ramp up, and then it may fall off, and it's not a square. So then you have to kind of program the squeegee length to get the maximum amount of square out of the curve. So it's difficult. And I remember one customer, because it was a pneumatic system, they had defects on a tick sheet at the very leading edge of the board, all along the board. And it was because the printer started at 20 newtons as a default setting. And then as it was moving across, you saw the force spike up. And if you have your stroke too close, you're not approaching those leading edge apertures with the right force, which is causing the defects in the volume fill not to be where it should be. So there's a lot of fine tuning that you can get out of making measurements to really understand what's happening.
So to fix that, did they just extend the print stroke?
That's what I recommended they do. Yeah.
Wow.
I was in the field not too long ago, and I observed kind of something directly related to what we're talking about. They were having like terrible print results in one stroke direction, and examining the squeegees, and they're in fine shape, and looking at the pressure settings, and it's the same between both the front stroke and the back stroke, and you could actually visually see the difference in print between the front and the backstroke. The backstroke would clear the stencil of solder paste real nicely, and those prints were beautiful. And then the front stroke would come, and it wasn't even evacuating the printing surface of solder paste, but all the settings were the same. And then the root cause ended up being that they had to do Z calibration on it, and it was off on one direction. So yeah, I can see how just because the software says that you're at 40 newtons doesn't mean you're actually at 40 newtons. And that, I think, Sean, is it your screen printer that just has one head, one squeegee?
No, it's got two, but it's got Z height calibration.
That's Yamaha.
Where my other one
Yamaha
didn't. And it was wild because I just for I don't know, I don't want to swear today, but blanks and giggles. When we were out in California, we did a drive-by, and we noticed that you were on the corner of the street, and I yelled out, Sivigny, and you seen us for, I don't know, I don't want to swear today, but blanks and giggles. I was like, let me see the difference, because I was running 5 mil forever, and then, I'm not going to get into it. I switched over
You
to a
swore
4
like
mil.
30 seconds into the interview.
Yeah, I know.
And it was the big one, Daniel.
That was 9:30, Sean, okay? This is 10 o'clock, Sean. He's a totally different guy.
People change.
And it was different. You could actually see there was actually a noticeable increase in the Z height from 4 mil to 5 mil. And it was just something I never even thought of or questioned, because the option wasn't there on my other printer. It was just slam this thing down and scrape across, right? But the new printer I have has the ability to do the Z height. And, I wouldn't never even thought of that could possibly be affecting anything into it. I think it's funny though, is because people are going to come to you because they want your machine. They want you to make sure their machine is good, but then also they're going to come to you to find out, like you said, like I never thought about, using your type of service. Hey, why am I having this defect? And then, so not only do you have to know the ins and out and the guts of this machine and how it's working and how it likes to be taught, but then also play detective and figure out, okay, well then how could I fix this issue? It's very interesting. It's almost like a twofold, two birds, one stone type of situation.
Well, it is for sure, because you don't You don't get a good process. You don't get good process capability without good machine capability. And the machine is the root of all of the variation that can be introduced into the process. So if you're seeing random print shifts and random placement shifts, it could be because there's loose mechanics in the system.
That's what drove me nuts about the Six Sigma class. I don't know if Elias, if it drove you nuts too when you took it, but for some reason, like I had this idea in my head that as long as you had your offset right, it would just print every single time, you know. And then we were taking this class and they started to show like the little drifts in each direction of, you know, and there was kind of like a random variation thrown in there. It just drove me nuts that a machine can't just go back and forth and deposit perfectly every single, like, you know, like a crosshair, the crosshair of like where, you know, your center is, and maybe you have a bunch of stuff over here, like just a little bit, but like,
yeah, you shouldn't even have a bell curve, right? You should just have
like
one straight line in the middle of the one straight line in the middle of the bar, right?
Does that exist? Have you ever seen a golden machine that just bullseye every time?
After the measurements, yes.
Really?
After the measurements and after the adjustments, yes. They are within microns of zero.
I'd be so scared to like have anybody touch it.
Don't look at it.
Yeah, don't even look at it.
Don't even look at it.
So there's I mean, Elias, to your question earlier about which machine, it's probably the printer, because there are so many parameters, so many process variables that need to be right to get it right. And this isn't all just the machine. This is aperture wall thick, you know, and area ratios and stencil thicknesses and all that stuff.
Quality of the foil, the metal itself, and the cutter and everything.
Yeah, and you haven't even started talking about paste or the board.
Handling. Yeah.
At the root of it all is having a machine that's going to produce a consistent result. And so we do know with that CM print tool we've been talking about is that we can quantitatively measure, and now we know that when you increase your squeegee force because the squeegee blade is not swiping the solder paste on the stencil, the more force you add to fix that problem, the worse your accuracy gets. We know it based on these measurements, and that's why we're measuring the accuracy during the stroke 4 times.
What's the reasoning for that?
It's because something is not in robust design, meaning it's either the stencil that is moving or it's the table that is moving. And the lion's share of the machines are designed with the table doing its rotation and then moving to stencil height.
Yeah, most of them, the stencil is fixed and everything else moves, right?
Most everything stencil is fixed. It's not the case in all of them, but most are fixed stencil and table coming up. And if you think about that table, the weight of that table at its most vulnerable position at stencil height, then you add squeegee force coming down onto it. It starts to move even through that 4 mil thick stencil. It's going to shift the table. If those bearings are not robust and there's any slop in that table, it's going to move. And
You've got opposing forces.
You have opposing forces, but the weight of the table doesn't take much to shift it in one direction. That's why you can see that variation. And when a work nest is not robust in terms of that stability as it's at its highest position, you get that variation, you get the movement. And we've done a test increasing the force every 2 kilograms every 10 prints. And in a stable machine, you can see the variation, but it stays in control. On an unstable printer, it goes off the rails and it's going to keep going. It's literally.
Have you done a 4 foot, like a large printer, like a 4 foot PCB?
Large board format?
Yeah.
Not in recent years, no.
I'm curious if that would be more difficult because it's such a large working area.
Mm-hmm. Well, you have large blades, which are very heavy. You need to calibrate the weight of the blade so that you're getting the right force in the system. So a lot of that stuff would need to be validated to make sure.
And the longer the board is, the more likely to have to be dealing with stretch and twisting and all kinds
Yep.
of alignment issues, right?
Yeah, for sure.
I've got something for you, Mike. Since we're talking about measuring force and we're at the screen printer, standing in front of screen printers and watching the print stroke and then watching the board separate and shuttle out, watching the stencil roll come up and wipe the stencil, it's made me come up with a theory that the under stencil wiping process is more brutal on a stencil than screen printing is. And I talked to Chris Shea about this because as you stand in front of the screen printer and you watch that roll come up, you watch the stencil deflect upwards and you watch that deflection roll all the way through the back of it. So as I was talking to Chris about it, she says, there's no setting for that, right? I said, that can't be. There's settings for everything. You can't adjust how, the Z of how far the roll drives up. Is that really the case? Is that an April Fool's prank she's pulling on me, or can you really not affect that?
In terms of the wiper bar that comes up to the bottom of the stencil,
Yeah.
some OEMs have it so it's adjustable.
Okay.
They have a screw in the middle of the wiper bar that they can screw in or out that then bows the bar a little bit.
Have you ever measured or quantified how much force is going up into the stencil during the wiping process?
No.
You're right though, Elias. Like I can totally see that online. There's way more deflection upwards, like on the screen, on the stencil cleaning than there is downwards with the squeegees. Way more.
My old printer was like that. The new one's not like this, but my old printer was like, you could just see
that thing drive up.
Yeah, you feel bad for the stencil a little bit. But yeah, the new one it doesn't deflect up as much, but yeah, you're giving me like flashbacks of almost trauma watching that thing just smash into there and blow up.
It drives up, and then of course it's trying to press up against the stencil to roll that paper to get the good fit, to get the good squeegee action, and then the vacuum turns on, and then you watch your foil get sucked into the aperture of the plenum bar, and then you're watching it do this, as it's cleaning. So what kind of wear and tear is that doing on your poly mesh over and over and over?
I think the majority of it, because when you're printing, in theory, it's a nice, well-supported contact process, and it's exactly the opposite when you're cleaning. So yeah, I'm not sure how to prove that theory. If you come up with any ideas, let me know. But
we also shown that in the Kaizen thing at my shop, the difference between using isopropyl, where you're just smearing that solder ball back and forth, right, versus using some type of cleaner chemical that's actually going to actually remove that from it, which would make it like less abrasive.
Solvent.
Yeah, it would make it less abrasive over time. But if majority of people are running isopropyl, it's going to be even add more to that wear and tear on it as well.
Mm-hmm. So that's an interesting point, Elias, on the stencil wiping scenario. Every tool that we have come out with to measure the whole line has been through customer need, and every one of them. We designed the first system to measure chip shooting accuracy, and then it went to QFPs, and then it went to printers, and then it went to the dispensing, and it exploded for the whole line. And so we're measuring board clamping, the wide board clamp in the work nest. We can measure that now. We have a small system that we can use, but we're also designing a bigger one now, so that when you have wide board, wide work nest, it'll be able to check both sides now better. And of course, now it's accuracy, it's print force, it's clamping force, but maybe there's a test for the wiping process just to measure force, but sure.
Yeah. In my world, everyone's always inquiring, how long does a stencil last, right? Which is my least favorite question because it's just impossible to answer. But, the desire is for increased stencil life. And there's only so many things that you can affect, right? You need to run the blade across the stencil every time you print. You can't mess with that at all. You can talk about how much force you're using in the squeegee and squeegee speed and so on and so forth. But I think cleaning is, under stencil cleaning is one of those areas where there's really an opportunity to gain increased stencil life, but you need to be able to clean effectively less frequently, or maybe not. Maybe you can continue to clean as frequently, but with less force applied on the stencil. So yeah, let's put a bookmark in that. Maybe we can work on something together.
Yeah, sure. The other point, I mean, if you don't measure, you don't know. I've coined the phrase, I haven't mentioned it yet, but there's a scenario with an encoder on a print head with closed loop feedback, and you expect that it's working. We did an initial evaluation of this print force on this particular OEM, and new machine install, brand new. And we tested, and I saw it lost 20 newtons of force from the start of the stroke to the end of the stroke. And this is at 100 Newton set point. We tested at 4 different levels to make sure that if you're printing at standard forces at 50 newtons, it's going to print at 70, 90, 110. And we lost 20 over the stroke. So the service technician took his camera and videoed the behind the head and watched the encoder moving during the stroke. That encoder is supposed to be locked, which locks the motor, which keeps the force consistent throughout the whole stroke. We found that there was a problem. We videotaped the issue, got a new encoder motor, put it in, retested, validated. Actually, then we had to use the measurement tool because the OEM calibration wasn't available, and then we fine-tuned and got it right back to spec. You don't see these things if you don't measure. That's the problem. There's not enough measurement going on in SMT to really understand where this variation is coming from.
Well, how long would like a process like this take just for like the printer alone?
2 hours.
2 hours and you could have the results back already, so your line can be back up and running almost?
If we have a program ready for the machine and the machine is ready, we can set up right after the last board leaves the line or the machine. And if we don't have a program, if somebody can set it up quick, maybe we're 2.5 hours.
So it's like I can't even use the excuse of, well, I don't want to be down for days, Mike. You know, like
it's definitely not days.
What do you do? So you actually measure the repeatability or performance of the reflow ovens also? How is that different than just like running a kick profiler through it and looking at the results?
It's not much different, but what we're doing with our test in the reflow oven is we've made our thermocouples a bit more robust, and we have a carrier board, from Global Point in Germany, and we upgraded the thermocouples. We run it 20 times through. We cool the system at the end for 6 to 8 minutes. But it's a longer term repeatability test to make sure that the oven is meeting those specs, peak temperature, reflow temperature, and soak time.
Without variance from board to board and such.
Right. So we cooled our tool. One, we have to cool it because we don't want the transmitter to get overheated. And, but yes, it's 20 times. It's a long test. Granted, but we can run other tests while we're running that test, if there's other stuff happening on the line.
If you don't measure, you don't know. Give us it's fun to talk about outliers and edge cases, right? What was the most painful no that somebody got to? Like what was the most dramatic, terrible, costly condition that you've shined a light on?
Mm-hmm. So we have it's part of our ROI case study series with graphics that we provided, and we diagnosed it was a placement machine. And the real expensive part comes in when they've diagnosed, they've calibrated. There's a service visit, $5,000-$7,000. Then they have to come in. It's still not working. They have to come in and they have to map it. There's another $5,000 to $6,000 of a service engineer coming in to map. Mapping doesn't fix it. Then they're thinking it's a placement head. How much is a placement head? You two on the top. Do you know how much a placement head is?
Probably like $25,000 about.
$25,000. You're
One on-
already close to $40,000 in diagnosing a machine. And then we, for the measurement, because we were still getting erratic results, we said, well, let's measure without fiducials. So we set up a test that shut off the fiducial read. We got the best result without fiducials. So that pointed immediately to the camera system.
problem.
There was a camera. What had ended up happening was that there was a loose screw on the lens, and every time the motion was happening, it was creating variation.
Come on.
I'm serious.
Yeah, it
So what did
sucks.
that customer spend in diagnosing the
Oh.
problem over how much time?
Oh.
How much they replaced a head?
Yes.
So there were 30 deep there.
Oh my.
You're $70,000 on
The
one
last
guy.
head the last head on my pick and place was $50K each. I don't know where Daniel gets this 25 from.
Well,
Wow,
he
I mean,
negotiates
he's
better
heavy.
prices.
They like
People
me
see his
better.
value. Yeah. So that's crazy. Somebody spent multiple 5 figures when it was a loose screw.
Wow.
That's the if you're not measuring regularly to keep track of these things, you start to see drift, you start to see problems, you start to dig in a little deeper.
You come in, you do the measurements. That's cool. You're gone. Somebody wants to do it more frequently. Can they get the tools that you use, or are they tools that you've developed? Or, I mean, how does that look? Can they buy them from you, or?
Sure.
So you actually sell the equipment that you
Can I
use
just-
to do these certifications.
Can I just, Mike,
Yes.
before you answer that, can I just say, I want everybody to know that this is not a paid advertisement. I know we don't ever
No,
talk
I'm
like
genuinely
this.
asking.
Like, honestly, but I'm saying though, like we don't really ever have people on to just talk about kind of their product and service, more generality. And I just want
Oh, that's
people to
true.
know that, like, this is honestly, like, we actually like this
That's
kind
true.
of
That's a
stuff
good
that he's
point. We
doing.
should be charging for this. Solid point.
Yeah. But
So-
I just wanted everybody to know, like, this isn't a paid promotion or anything like that. We just actually are honestly curious. We like nerds, data and
Well,
stats.
yeah.
This is very fascinating.
I think what Mike
Sorry.
does is kind of so much of a niche that it's like hard to speak in too much of a
Who are you
generality,
going to
right?
compare
Like,
against all the
yeah.
other CTACs? I mean, come on.
Yeah.
You'll see at Apex, it'll be CTAK,
Oh, no.
and I'll be TAK. That'll be my magnet,
You're
Mike.
Are you going to be the special guy in the room?
Kid,
C-TAC and
CETAKF.
F. C-TAC and F.
Sorry, Mike.
So
go ahead.
we
I'm
have-
sorry to interrupt. I just want anybody to think like this is paid or sponsored or anything like that, because it's honestly, you
No.
have a really cool service that you offer, and it's very unique.
It-
But go ahead and answer
is-
Elisa's question, please, about your
It
their
is
own
very
type.
unique. I agree. I love the position that we're in the industry, third party independence. And yes, the equipment we have, we initially designed everything so that we could provide a service in the industry. And from there, we started to make it more aesthetically set up and functional for rolling around on a production floor, so that you can take the machine and take the measurement directly to the machine. If there is, and this is using a relative based measurement methodology, that's how we can be mobile without a temperature controlled room, which will impact your measurement error. If you're using a CMM, which you can do all of this in a CMM, but it's very arduous and it's very time consuming. Just to collect the data, and then you have to download it and you export it and analyze it and then figure out what you need to do. And
What's a CMF?
literally CMM, it's a coordinate measurement machine. And those tools can be used, absolutely, but they are not designed for this type of work. And literally minutes, we can have results in minutes and adjust a machine within minutes. As long as we have access to the software, that's how fast this adjustment process can be. So yes, tools are available. If anybody is interested, sure. Yes, we sell the tools if customers want.
I'd have to assume you get job offers left and right of people like, Mike, just please work for me and fix all my machines constantly.
In 25 years, this year is 25 years, by the way. Never I have people asking me what the best machine is all the time,
Sure.
Sean.
You probably have like podcast producers begging for jobs all the time from you, though. Oh, it's probably common.
No,
I don't know why you
it's-
won't publish the list of who's good and who's bad.
no, I mean that would undermine my whole business.
What if you
The
just
whole
started like a
business of measuring.
blackmail model? Like, you could, for a certain amount every quarter, you can keep your name off the list.
Yeah.
I can put your name on the list you want or keep you off the bad one.
Or like you have like you ever see like those movies like If I Die, like they'll like send it to like a post office and like somebody open this safety deposit box, right? And then you have the list on there.
Yeah, it's like, hey, Mike, you've probably been running a successful business or whatever, but here are these other ways to run an illegitimate one. Okay, ready?
Yes.
Yeah, Sean, this is why you never have to worry about explaining that we're not a commercial podcast because of moments like these.
So, but I want to get to a point here. If you think about the DMAIC principle, define, measure, analyze, improve, control. And the whole aspect of this whole measurement process uses the DMAIC principle in its entirety to improve the process. And when you measure the process, you can improve the process. Measure the machines, you can improve the process. And what we have found, and this is an intrinsic feeling, and I know this because I've measured machines year after year after year, there is a lion's share of crap that you have to go through to get the machines to a good point in that first year. And then it gradually gets easier each year to adjust the machines and keep them in spec. And when you start to exercise that on a regular basis, the machines are down less. They are more efficient. You can put more product through the line. You're getting more capacity. You're creating less defects. That's more productivity. And when you have more productivity and less rework, your profitability starts to skyrocket. That is really the message behind measuring machines to improve the profitability of your SMT lines. No comments? Are you letting that sink in, Sean?
All right, so I got ADD in case you didn't notice. And the way you said DMAIC at
Everyone's
first,
noticed.
it got in my head because I was like, I thought you said a different word, and then you started doing the acronym spell out, and I'm like, wait, he said DMAIC, but you said it differently. So in my mind, that's where I kind of was while you were talking. I apologize. It's just my brain is it likes to go where it goes.
You can watch it on replay.
He's like, so yeah, if you could just repeat everything you just said, that'd be.
And Daniel and I are just programmed to when we see Sean's mind broken, we don't bail him out.
We just wait for it. Yeah.
I'm a show pony, Mike. I'm just here it's the hair. That's why they got me here.
Yeah, that's good. You add a nice element to it, Sean.
Thank you, brother. But I am curious though. I would assume the machines are getting easier to fix, but also becoming more accurate versus what was considered accurate 10, 15, 20 years ago.
Mm-hmm. So we have customers that are using 20-year-old Siemens equipment in Germany, still using that equipment because they have our system. They're using the system to keep it finely tuned and accurate and regularly checked. And their product complexity has increased. Yes, I'm sure they've upgraded the machine where they need to in order to place smaller components, but they're using the same equipment. So if you think about the return on investment for that placement machine or that line over 20 years, how much profitability came out of that line with everything being done right the first time? That is one of the other major topics is getting it right the first time, because as Ultra HDI and small miniaturization of product comes down the line, you cannot rework that stuff. You degrade the long-term reliability of the product when you touch it with a solder iron.
Mike, you mentioned the 20-year-old line that was still up and running. Was that because you had a weekly contract where they just brought you in to keep maintaining it, or do you somehow empower the end user to monitor the process themselves in between visits from you?
Yep. So in that particular scenario, they purchased our equipment, and what they ended up doing, so they made regular measurements every quarter, every 6 months, every year, whatever it was. Then they developed a line measurement solution, and we helped them set this up. So this is using a few glass boards and placing all of the chips for the whole line onto 1 or 2 glass boards and setting up multiple measurement projects in our software so that you run in I'm calling it my line SPOC, statistical process optimization control scenario. And it's a quick production run that runs down the line. It's scheduled in production. It's less than an hour. It's set up so that it runs quick. It minimizes the client downtime. And you get, as soon as the last board comes off, you start putting stuff in the measurement system, the line changes over to the next product. And what's happening is you're measuring offline, at the line, but offline, so that you can set the line back for production. And those measurements are then plotting SPC points for each machine. And if the machines are staying within control, then you don't do anything. You let the data collected discern or decide what to do. And as soon as you break an upper control limit, then that's a flag to say, okay, we need to do something with the machine. Either we do it now or we do it at the next PM interval. So then you have a little bit more control about understanding when to do the work, schedule it in so that you're not down when you're in the middle of a product, which causes lots of issues and costs a bunch of money. And that allows you to collect data on a more frequent basis. That's exactly what they're doing. They're running this on a very regular basis, and they're just keeping the line fine-tuned. And they've developed a process that really works for them. And that's what I think needs to happen in that same scenario, like in your facilities, that type of production run where you collect in the data. You know, it can be run through a service. It can be run through renting a product. It can be run through buying the product. But measuring more frequently helps you keep tabs on the equipment and keeping them fine-tuned.
Well, if somebody that's consuming this wants to get a hold of you and start measuring and kind of see where they're at, how do they do that, Mike? Where's the best way to get a hold of you?
So depending on where you are in the world, if you're in Europe, it's cetac.com, CETAQ.com. If it's in the Americas territory, all of the Americas, cetac-americas.com. And, we'd love to hear from you. So
awesome. Well, we sure appreciate talking to you. It's really fascinating. We talked to a lot of different people, and again, kind of to the point earlier, like this is pretty unique, pretty niche. So I know I just have a lot of genuine curiosity about it, and these guys do too. Data's fun.
It is amazing what you can see.
So
yep.
Awesome. Well, thank you for joining us, and thank you all for tuning into this episode of the Decode podcast. We'll see you next time.
All righty, guys. Thank you so much. Appreciate it.